Hello YouTube, this is Frank, and this is December 29th, 2025, and this is my 99th video and my second GPS to chrony video. And today's topic is concepts of a plan. We're trying to go to chrony, and this is 2 out of 20, and the goal of the project is to replace GPSD with my project, writing to that shared memory, and that's the whole goal. So here's concepts of a plan. That's what we're doing today. We just want to write to the shared memory and then read it. Now if we can do that, then the rest of the project should be easy. We should be able to send those GPS sentences through my project over there to chrony. Chrony does not have it does not include those the NMEA drivers, and so my project will replace GPSD. And I will let me move my board down, and I'll show you what I got. Let's see. All right, let me see, where am I? Frank, let's see. I have no financial, employment, personal, or family relationship with any brand or product. I purchase products that appear in my videos with my money. I'm retired, I just put her around. AI was not used in this video. This is our, what we want to do is send those GPS NMEA sentences. We want to read those with my GPS program and send those over to chrony. Concept. Now this is the key piece of my project. If we can get this part working, the rest of the project should be not too hard. And I will be using the public domain programs in Professor Schaumann's Advanced Programming in the Unix Environment class. Week 8 as a springboard to feed those sentences over into chrony. I put all of my make and C source files into my Google Drive, and I'll link that to my video, but I just want to show that there. The issue, people have no trouble reading those GPS sentences, but the problem is how to feed those sentences into chrony. And so we just want to write 2 simple programs just to demonstrate the concepts of a plan. This is critical. So if we can get our critical part of the plan working, all of these tasks will be easy to complete. Well, not too hard. Video 2, concepts of a plan. And we just want to write 2 simple programs. We want to write to a shared memory and read from a shared memory. So we'll have a program that writes to the shared memory and a program that reads from the shared memory. And so this is kind of what GPSD is doing. They're writing to a shared memory to chrony. Now that's one way to input that GPS time. Now they've got several methods to do that, but I'm going to use that shared memory method. Yeah. See, this is what we really want to do right here, is have a simple program that writes to the shared memory and reads to the shared memory. And if we can get that to work, and also using the chrony-like structure, then our concept of a plan will work. And what we're doing is taking that shared memory key and the structure from chrony and just put that into our simple program, our simple write program, and our simple read program, and we'll just try to read and write those to and from that shared memory. And this is Professor Schaumann's class. Let me just show you what I'm talking about. Professor Schaumann, advanced programming in the Unix environment. It's in all of the programming now is done in C, and we'll have to be working with C. And he uses all command. There's a command line shell interface. Let's see now. Just kind of scroll on down. There it is right here. The textbook, Advanced Programming in the Unix Environment, 3rd edition. Now, if you want to get a copy of that book, it's the 3rd edition. Let's see. Scroll on down, and you scroll on down to week 8, 7, 8. Yeah, here we go. And lecture 2, well, segment 2 is where he talks about the shared memory, and down a little bit further, see, he has a shared memory demo, and we'll just be copying that program to use as a template for our read and write programs. Let's see, where am I at? Oops, wrong one. Okay, now I need to rant. Now this project now is written in the C language. Now this is not a rant against C. Now I've programmed professionally in C for about 30 years. But it's a rant about making the same mistakes year after year after year in the C language. And so my goal is to stop making those same mistakes year after year after year. And to show you kind of what I'm talking about, the common weakness, let me show you what the common weaknesses are up here. So top 25 most dangerous software weaknesses. That's what I'm talking about. And here's the top 25 for year 2025. If you kind of scroll on down here, out of bounds write, use after free, out of bounds read, buffer overflow, null pointer dereference, stack-based buffer overflow, heap-based overflow. And see, and see, these just happen. These year after year, you see these mistakes made. And let me just let me make sure I'm on my. Now, let me just show you this this list. We'll pick one of those most dangerous software weakness, and let's put it in that the CVE. Now, you really don't want to be listed in a CVE. And so if we were to, I think it was common weakness 787. I think that was one of them. Yeah, out of bounds right. And so look at these companies here. Canon, one of their printer drivers, and we kind of scroll on down here. WatchGuard, out of bounds read and write. That's for that's a nasty one there for open software. Rockwell, Chrome, Google Chrome, they got a out of bounds write. they got another one right here. Autodesk. Yeah, you kind of scroll down there, and you'll just see, these large companies, multi-million-dollar companies, billion-dollar companies. So that's what I'm talking about. Now let me get back over to my. Let's see now. Let me get back over to my notes. So yeah, see those huge companies, they're still making the same mistakes year after year. Now those companies, they have teams of programmers and quality control and quality assurance engineers and managers that are 10 times smarter than I am. And there's companies, then they can purchase those expensive diagnostic tools, and they're still making the same mistakes year after year after year. I'm going to tell you now, I make mistakes. Now, I don't know much about those GPS receivers, and I kind of expect to make mistakes regarding those GPS receivers. But see now, what I'm ranting about is I don't want to make the same mistake year after year, those same mistakes that are on those top 25 list. So in this project, I'm just going to mechanically test those memory pointers and access and error messages, error returns. Now I am not a 10x programmer, but I can be a 10x obsessive compulsive top 25 list freak. So no matter how trivial, I'm just going to dogpile those memory access with assertions. I can do that. I'm not very good. I'm not a talented programmer, but I can do those memory access assertions. So yeah, this is what I'm talking about. It's just mindlessly just initialize the pointers, check the pointers, decommission the pointers, mindlessly just check the buffer underflow and overflow, and just mindlessly check those returns and error numbers from the functions. Yeah, we'll just at the beginning of the program, we're going to initialize everything. We'll check and assert those memory and pointers, file descriptors for out of bounds access. We'll store a value in those pointers and decommission any resource. If we open a resource, we'll close that resource. And now there is nothing in our concepts of a plan now that's going to require or need efficient code. So we're just going to mindlessly insert these tests to catch my programming errors and design flaws early in the plan, because we'd be better to catch these errors and flaws early, demonstrate that the thing works. So yeah, we read that. We read our top 25. And we'll try not to do them. That's the whole goal of this, is just not to do the top 25. And let me just show you. Now, there are a number of weaknesses, and you need to be aware of those if you've never done, or if you haven't done a whole lot of C programming. Because if you go over here and go to the access content right there, that the list and the list and the current version right there. Mash it and kind of scroll on down a little bit. And software written in C. If you mash that one, software written in C, there's a whole bunch of weaknesses. And I've done probably 90% of these in my programming over the 30 years. So, I mean, I'm pretty familiar with all that. But if you haven't, seen this. I just wanted to kind of to be aware that, you know, in C programming. All right, let me get back to my notes. Now there are a number of tools, open source tools to find those top 25 weaknesses. Over the years, now they've got those tools that will help find those mistakes. Now, I kind of wanted to spend some time with this, you know, to just emphasize now that we'll be concerned about, you know, these top 25 dangerous software weaknesses, and this is what I will be using. But the compiler flags, the banned functions, just mindlessly check for those errors and returns from functions. clang-tidy, sanitizers, a static analyzer, a dynamic analyzer, and the GNU debugger, and just step through the code and watch the code. So that's the end of that one right there. And what I'm talking about with the compiler flags, if you haven't seen the flags, let me just kind of show you what I'm talking about. This is the JPL coding standard from NASA. And if you kind of go down to about page 8, I believe. Let me just kind of scroll down here. Where is it? Yeah, page 8 right here, and they have a number of flags that they're recommended. Now I've included all of those warning flags in my program, my makefile, and Airbus, they have some additional flags. Let's see, now if you kind of scroll on down here for GCC, they've got a number of flags here that they recommend. That's it, just keeps, they've got a whole list of flags right there. And those are sanitizers, but let me, C-Lang, they have the same thing with C-Lang. They have just, yeah, a whole bunch of, oops, let me get that scroll right there. See all these flags right here? Let me get back to my notes. And I need, hold on just a second. All right, let's see now, the banned functions. Let me just show you Google's banned functions. It is Google. So they've got a list of functions that they ban in their code, and I use their header file, and they've got a whole bunch of functions that they ban in their code. Let's see now. Now for those functions that we need to check the return and error number. Let me show you this right here, the cert C coding standard, and I believe I got it right here. So let me cert C coding standard. 2016 edition, and let me just show you. See, oops. They do have a, see, we can reproduce without modification and distributed form. So we're okay. Not violating anybody's license here. So it's on page 392 is what I'm talking about. Go to page 392. See 392. And see right here, detect and handle standard library. See right here, this is what I'm talking about. It's essential that programs detect and appropriately handle all errors and implement a consistent and comprehensive error handling policy. Now, see that they've got a list. See right here, the list. There's the list of those functions that they want you to to test. And now I wanted to bring, they got several dozen of these functions, but I wanted to bring that to your attention. Let me get back to my notes here, because I've got, I put that list in an ASCII file right here, put all those functions in there. And so what I do is, let me get back to my notes right here. See, I just grep those, I got all those functions in that ASCII file right there, and I just grep, if I've got a program in C, or my C source file, I just grep for all those functions. And if there are any functions in that program, source file, I go ahead and try to test our return codes and error codes. Now, CLang, they've got a tidy tool, and let me just let me show you that web page for tidy. Let me see now. Tidy, CLang tidy, and they have there are a number of checks that you can do for your source code. I mean, all of these groups of checks. See, there's the cert thing. Cert. Google, they have Google's has theirs. And they've got a list. Let me get back up here. They've got a list of, and they've got just, I think they've got hundreds of these checks that you can do. See all those, the bug prone checks, assert checks, Google checks, miscellaneous. They've got so anyway, that's kind of show you the picture right there that CLang tidy is one way to kind of lint through your code. And I've got in my makefile, I've got if you put tidy check, it runs those that CLang tidy with the options. Sanitizers. Yeah, let me show you the sanitizers. Let me get over here. Google sanitizers. And they've got a number of. See, they've got a number of checks in their sanitizers that you just link with your with your program, or it's a runtime library, and checks for all the use after free, buffer overflows, use after return. But let me just kind of show you now. Now I do a lot of my development with on the Intel systems there. Now I do have a bunch of those single board computers. Now I will usually develop on Intel and usually Linux, because those sanitizers work in Linux and those Intel processors. So I kind of wanted to bring that to your attention. A valgrind, you have to turn off those sanitizers if you want to run valgrind. And let me just kind of show you my makefile. Let's see here now, where's my... This is one of my makefiles. We're going to, let's see now. Start with clean. That cleans up the old logic files. Tidy check. I've got tidies in there, and then just to make the file. Let me leave that up. You can change your compiler. Choose your compiler. It works with GCC or CLang. The scan build, you can turn it on and off. I got a switch right here. The scan build, it has issues with those Airbus flags, so you have to kind of. I've got a switch right there. And same thing with valgrind. Valgrind has his issues with the sanitizers, so you can turn those issues on or off. Those sanitizers. And here's those tidy checks. I've got a section for my tidy checks, and you can just put as many of those tidy checks as you want to. You can turn them on or turn them off. There's even extra options right there. And this is my, for that JPL coding standard right here. This is what from that NASA JPL publication, and then the Airbus Security Lab. This is for GCC, and there's all the flags from GCC, and then for CLang, the CLang comes next. And see, scan build, it kind of has issues with some of those CLang flags. So I've got a switch, you can turn those off. Let me see now. Valgrind, I've got that. I had that switch for valgrind. Valgrind does not work with those sanitizers, so you have to turn valgrind off. Otherwise, see right here, I've got it. I had that switch off, but here's the. You have to turn those sanitizers off, and I think that's pretty much it. And you can. These are just rules here on my in my makefile for the tidy check and clean program right there. So I kind of wanted to show you my makefile. Let's see now, where we at? Scan build. I did show you the scan build web page. Showed the makefile. Showed valgrind. Did I show valgrind? I think I did. I don't remember. Let me back up now. Did I show those? I forgot if I showed those or not. Let me make sure. Where was I at? Sanitize. Oh, I was at the sanitizers, I think. Yeah, I was at the sanitizers. I forget where I was at here. That happens a lot. I'm old. There's the sanitizers. The next one, the scan build. See, Lane, they have a scan build, and that's a static analyzer. Let's see. I think there's a section right here for scan build, and it just pretty much run it. Use your makefile as input to that scan build. All right, let me get here to my notes. That was scan. Let me hold on just a second. I got. All right, let's see now. That was a scan build. Let me move that out of the way. Scan build. Valgrind. Valgrind is next. And that was valgrind. That's for dynamic analysis. So if you can run valgrind runs on your it executes your code, your executable, so you can see what your program is doing while it's running. That is a very, very helpful utility there. Let's see. And GNU debugger. I always single step through my program just to watch what that see if I can find my mistakes just by watching what the single stepping through the program. There's the GNU debugger. I'll be using that. Not yet. I put all the source code on my Google Drive. Yeah, now I just wanted to spend just a little bit of time at the very beginning of this project to introduce those tools that I'll be using. Because even Professor Schaumann, he didn't go through these tools. So I kind of want to help kind of fill out the tools that we can use to stop making those top 25 mistakes. Yeah, here we are. This is concepts of a plan. Yeah, now if you don't want to watch the rest of the video on a clean machine, just download that source file from Professor Schaumann, download the chrony software, copy that structure and the key into that demo program, compile and run that simple program. Now I've got a test machine, and let me just kind of show you. I think I've got it set up that if you just want to, I just want to show you the quick. Let me see here now. Here it is right here. Oops. I thought I had it all set up. Here it is right here. Yeah. See, the chrony is not installed. GPSD is not installed. And let me just kind of show you. And this is my directory where I kind of developed. I'm working with that with the source code right here. And I believe, let me see now, there's the executables are right here. So let me just kind of show you what I'm talking about. Write, I just want to demonstrate that we can write to that shared memory. There it is. I'm writing to it, and I've got a local structure right there, and I've got several different options here. I think we can, like I wanted to zero out everything, so that works. And let me just see if we can read. We can read it. Okay, there's our read. And let's see if we can, write it. We write it with some time in there. So there's we wrote some time in there. And let's see if we can read it. There's our read program. See right here. All right, and there's our size of our structure, 96, right there. And if we do the IPCS, that program, I'm drawing a blank, but anyway, here's our message passing queues. There's our shared memory segment right there, and there's that key that we were looking at right there. All right, I think that's what I wanted to show. I think I had one more. I thought I saw one more. There's the tidy check there. If you see right there, if you put tidy check on when we're making that those files, I just wanted to kind of show you that. There's all kind of checks you can. There's just dozens of checks you can do on your source code. Let me get back to my notes. I wonder what I was doing. Let me. Yeah, that was just a quick demonstration there. Show everything works. That's the most critical part. The details, let me show you now. This is kind of the details of what I just did. This is my one of my networks in my house right here. Got fiber coming into a router, and I'm in my TV room. I'm on this PC right here, a Windows PC, and I'm going through the network to that i5 computer right there. That's what I was just doing. It's a $55 refurbished Dell Octopad i5 65T with a $12 USB thumb drive. Windows 10 reached the end of life in October of 2025, and I just kind of kept an eye out for those Windows 10 computers, those old ones that might be kind of, something I can afford. It's a Intel, so we can run those sanitizers. Let's see now. Let me get back. Here's my TV room. So we're in my TV room, and then the going over the network to one of these GPS machines over there. Chrony does not have any built-in drivers, GPS drivers. So now one of the goals in my retirement was to work through that advanced programming in the Unix environment, and I did buy the first edition of that book back in the 1990s, but I never got very far. Let me show you now what I'm talking about. This is the Advanced Programming in the Unix Environment, 3rd edition. And I believe hold on just a minute now, it's on page 571 is the, that's where the shared memory starts. And also now with Linux, there's a big old the Linux programming interface, and it starts on the chapter 48 for the shared memory. System 5 shared memory. So those are two resources that you might find useful. Let me see now. Yeah, Professor Schaumann, he put all of his lecture videos, source code on the interweb. He put all of his code in the public domain. Yeah, when I was working through week 8, you could really, I mean, it was just obvious. There would be no trouble to build an interface to chrony. Let's see, I think it showed Professor Schaumann's web page. Let me see right here. Yeah, here it is right here. That's his web page. Yes, week 8. Go down to week 8. Interprocess communication, and that's that file. And I believe I've got a copy of that. Here it is. Here's his original shmdemo.c file is in the public domain. And yeah, and I was looking through his code because he goes through all these code examples in his lectures. There's the shared memory ID and the size. All you got, and that was, I mean, it should be simple to interface with chrony. So you just get your key. And then when you got an ID, get your pointer to that shared memory, and then you're ready to read and write to that segment right there. And here he's detaching that pointer. So that was so that program was not very long. I mean, that's it right there. And when I was working through that. Through Professor Schaumann's class, I thought, yeah, that won't be very hard at all. And that's what, let me show you chrony's short code right here. Now let me just kind of show you what I'm talking about. I downloaded the chrony source code. Let me just show you. See right there, if you download chrony's source code, just get whatever their latest source code is. And I believe I've got it right here. And it's, yeah, this, oops, I kind of got ahead of myself right here. It's, if you kind of go down to this is their source code, kind of go down. Oh, now let's see now. Right here. See right there? Their reference clock, their shared memory reference clock right there. That's what I'm looking at right here. And if you kind of scroll down, yeah, see right here? There's the key, the shared memory key, and here's the shared memory structure. And all you got to do is copy this structure over there to that demo program, and we can read and write it. And see right here, look, he's got the pointer to that structure. He gets see right there, he getting with that key, gets his ID, and then with his ID, he gets a pointer to the shared memory, and he's ready to go right here once he's got that. And let me kind of show you this right here. So he gets a local structure, and then he's got a pointer over there to the shared memory right there. So right there, he's getting this pointer to a shared memory over there, that structure. And he's making a local copy right here. That's what that is. That he's working with his local copy. And once he's got everything, well, he starts out setting the valid field to 0, and he sets all of his local stuff. And then when he gets ready, I believe then he passes it on over to this, when he gets everything ready, he passes that on over to his, the rest of his processing right there. So yeah, that's not, I mean, we can do that. It's just, the problem is, I mean, it's just not very obvious. You have to kind of, dig through all that, but it's not hard. Yeah, so we can just get a, simple read and write program, and we should have no trouble. Yeah, so there's a key structure. We did that. I got the chrony write to a shared memory and a read. I demonstrated that. Compiler flags. I showed my compiler flags. Make of the various make here options. But for both of them, for both my read and my write and my read, I showed my band header file. Let's see, what's I do? Oh, I showed the returns from the functions. We need to. Let me just show you. I don't think I demonstrated that. Let me just kind of show you what I'm talking about. If you hadn't seen that. Let me see. I think I had it set up right here. Did it go past it? I think I went past it. I'm going to have to type it in if I can't find it. I thought I had, there it is right there. I'm going to search for those functions in that in my source code right here. See right here, and it'll have a lot of false positives, but see there right there, that exit. That's one of my functions that I'm looking at. Shared memory get, you got to check that one. Shared memory attach. So yeah, just go through your through that list and check all the functions and error codes, the returns and error codes. Let me see now, where am I at? I think I showed how to do the tiny check. Scan bill. Let me just show you how to do the scan bill, because that one is just a little bit. It's not very. I mean, it's not obvious. It'll show you some error messages. So let me just show you that. So I've got. Let me see now. I've got to show the. Let me just show you. I wanted to show the scan bill. I think I had it right here. Let me just get back here. So we start out making it clean, because it's going to build the source code again. So you got to start out clean. Right here, you have to start out clean. So it erases the object file and the executable. And let me show you what I'm talking about. If you try to scan build it, see, it has an issue with those Airbus flags. So you have to edit that makefile. And let me. And I kind of, let's see now, where's my scan build? Here it is right here, scan build. I've got a thing. It's if you turn that on, it, let me just show you right here. See, it turns these flags off right there, so you can run scan build. Yeah, there we go. See, it did the static analysis. No bugs found. All right, let me. Oops. I'm gonna turn it back off. Yeah, let's see now, did I go past it? I went past it. That's probably, you can probably think of a better way to do this, but this is just me. All right, let me see what I got over here. Get back to my notes. Valgrind, that's checks your program while it's running. Now, let me just kind of show you that too. I've got it set up here. So if we run the, let's see, where's my valgrind? See right here, if we run valgrind. See, valgrind, it has some issues with those sanitizers, so you have to turn the sanitizers off. So let's go back to our makefile. And it's kind of same thing. It's kind of similar to that scan build. Here's the valgrind. Turn valgrind on, and see. Let me just kind of show you what I'm talking about. Yeah, right here. If it's off, we run the sanitizer flags. But if it's else we comment the flags off. The sanitizers, we comment that off. So now we should be able to make it clean. Yeah, make it clean. And now we should be able to run valgrind. Yeah, this is, see, it runs your program while it's running, and it checks the heaps. One block allocated, one free. All blocks were freed. No errors. See, that's what we want right there from valgrind. And while I'm here, let me turn that, because I'll forget. I'll turn it off. All right, so I got it turned off. So I don't run valgrind every time I run the program. I'm testing the program, but I do try to run it often. Let's see now, where was I at? Let me see now. Yeah, now that's the end of my video, and I wanted to show you the tools that I'm using, and we'll put all of my source code and make files on my Google Drive. I'll have it linked to the video. I'll have the link in the description to the video. So, all right, thank you for watching. Happy New Year.